everyone, today we are going to discuss the difference between minor, principal minor, leading principal minor of a matrix. Okay, let's start our discussion. In this video, first we will discuss the definition of minor. After that we will discuss one example, and second we will discuss the definition of principal minor, leading principal minor and their examples. Okay. Minor. The minor of an element in a matrix is the determinant of the smaller matrix that remains after deleting the row and column of that element. For an element Aij in a matrix, its minor denoted as Mij is found by removing the ith row and jth column from A. Here A is matrix and calculating the determinant of the resulting submatrix. If we are taking 3 by 3 matrix and we are going to find the minor of the element A12 in that matrix, we have to delete the first row and the second column, and after that, after deletion, we will get one matrix. We have to find the determinant of the remaining matrix after deletion. If we are dealing with the element A12, if we are going to find the minor of the element A12, we have to delete the first row and the second column from that 3 by 3 matrix, and we have to find the determinant of the remaining matrix. Okay, let's see one example. Look at here. A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. We are going to find the minor of the element A23. Here A23 equal to 6. A23 equal to 6. We are going to find the minor of the element 6. So we have to delete the second row and third column. So the remaining submatrix is 1, 2, 7, 8 because we deleted third column and the second row. So the remaining submatrix is 1, 2, 7, 8. We have to find the determinant of this submatrix. So determinant is equal to 1 into 8 minus 2 into 7, that is 8 minus 14 equal to minus 6. So the minor of A23 equal to 6. A23 equal to 6 is minus 6. Here A23 is equal to 6 and the minor of that 6 is minus 6. I hope you got the idea. If you have any doubts, just comment. Next we are going to take the definition of principal minor. The determinant of a square submatrix formed by deleting any k rows and the same k columns, not k rows and their corresponding k columns. Or a minor of a matrix A of order k is principal if it is obtained by deleting n minus k rows and n minus k columns with the same numbers. That is, if we are dealing with a 3 by 3 matrix, we can find the principal minor of order 1, principal minor of order 2 and principal minor of order 3. That is, just look at this equation n minus k. Here n is the order of the given matrix. If we are taking 3 by 3 matrix, n is equal to 3. And if we are going to find principal minor of order 1, k equal to 1. If we are going to find principal minor of order 2, k equal to 2, just like that. After calculation, if we take n equal to 3 and k equal to 1, 3 minus n equal to 3 and k equal to 2. So we get 3 minus 2 equal to 1. That is, we have to delete one row and one column. Okay. We are going to find the first leading principal, not leading principal, principal minor of order 1 of this matrix. We are going to find principal minor of order 1 of this matrix. Okay, just write this matrix somewhere. Okay, here the given matrix is 3 by 3, so n equal to 3, and we are going to find principal minor of order 1. So n minus k equal to 3 minus 1, that is 2. So we have to delete two rows and two columns. If we are going to delete first row and second row, we have to delete the corresponding columns, that is first column and second column. So the remaining element is 9. So the determinant of the element, not element, the matrix 9 is 9 because in that matrix only one element. So the determinant is 9 only. And if we are going to delete first row and third row, we have to delete the corresponding columns first and third. So the remaining entry is 5. The determinant of this 5 is 5. Similarly, if we are going to delete second row and third column, second row and third row, we have to delete the corresponding columns second and third. So the remaining entry is 1. So the determinant is 1. Okay. That we wrote here, first order principal minus m1 equal to m11, that is 1, m2 equal to a22 equal to 5, m3 a33 equal to 9. Okay. Just look at this matrix. We are going to find, not look at this. Okay, we are just taking this matrix only. We will discuss leading principal minor after this definition and example. Okay, so just look at this matrix. We are going to find the principal minor of order 2 of this matrix. So the given matrix is 3 by 3 and we are going to find principal minor of order 2. So 3 minus 2, that is n minus k, 3 minus 2 equal to 1. So we have to delete first row and corresponding column. If we are going to delete first row, we have to delete first column. So the remaining matrix is 5, 6, 8, 9. To find principal minor of order 2, we have to find the determinant of this matrix. If we are going to delete second row, we have to delete corresponding second column. So the remaining matrix is 2, 3, 7, 9. We have to find the determinant of that matrix. Similarly, if we are deleting third row, we have to delete third column. So the remaining matrix after deletion 2, 1, 4, 5, we need to find the determinant of the matrix. Okay, so we get 3 principal minors. Okay, of order 2 that we wrote here. Just read and understand what we discussed earlier. Okay, next we are going to discuss the definition of leading principal minor. The leading principal minor of A of order k is the minor of order k obtained by deleting the last n minus k rows and columns. I will read this again. The leading principal minor of a matrix A of order k is the minor of order k obtained by deleting the last n minus k rows and columns. In principal minor case, we just delete n minus k rows and corresponding n minus columns. But here we delete the last n minus k rows and the last n minus columns. Okay, just keep that in mind. The last n minus k rows and the columns. Okay, let's look at one example. Look at this example. A equal to 2, 1, 3, 4, 5, 6, 7, 8, 9. We are going to find the first order leading principal minor. Leading principal minor of order 1. Order 1. So here n equal to 3 because the given matrix order is 3. And we are going to find first order leading principal minor. So k equal to 1. So n minus k, that is 3 minus 1 equal to 2. That is, we have to delete 2 rows and 2 columns, but we read one word last n minus k rows and n minus columns. So we have to delete two rows, so second and third rows. Last two columns, second and the third column. So the remaining entry matrix is only 2. So the determinant is 2. That is, the first order leading principal minor of this matrix is 2. Okay. In second order leading principal minor case, n equal to 3, same here, because the given matrix is order 3, and we are going to find second order leading principal minor. So k equal to 2. That is, n minus k equal to 3 minus 2 equal to what? 1. So we have to delete one row and one column. Last one row and last one column. That is, we are going to delete the third row and third column. So the remaining matrix is 2, 1, 4, 5. We need to find a determinant of that matrix. That is the second order leading principal minor of this matrix. Okay. That we wrote here 2, 1, 4, 5. Determinant 2 into 5 minus 1 into 4 equal to 10 minus 4 equal to 6. So the second order leading principal minor of the given matrix A is 6. If we are going to find the third order leading principal minor of this given matrix, the n is 3, same, because order is 3 and k equal to 3. That is, n minus k equal to 3 minus 3. That is, we have to delete 0 rows and 0 columns. Last 0 columns and last 0 rows. So that means we don't have to delete anything. That is, the third order leading principal minor is the determinant of the original matrix. Okay. That we wrote here, third order leading principal minor. The whole matrix, 3 by 3 submatrix, that is whole matrix. Determinant of A. We have to find the determinant of the given matrix. When we find, we will get minus 9. So leading principal minors of A, 2, 6 minus 9. 2 is first order leading principal minor, 6 second order, and the minus 9 is the third order leading principal minor. Okay. Okay, thanks for watching. Don't forget to like, share and subscribe for more